Hello, innovators. I'm Dustin Miller, PolyInnovator. Today, I'm talking with Noah Healy, founder of Coordisc, a coordinated discovery with the market, which we'll get into what it is in a moment. A data scientist, a developer, recreational mathematician, public speaker, game theorist, and nuclear engineer. Thank you for joining me on the Polymath Podcast, Noah.
Thanks for having me here, Dustin.
Dustin Miller, PolyInnovator.
So we're here to talk about game theory, data, engineering, exciting math, and your unique company. So the way I like to start off the show and kind of keep things going in a unique way is to share something about yourself that no one knows about you.
Well, no one knows. That's reasonably rare. I'm fairly open about things, but something I haven't sort of talked about in public for quite some time is that I almost died of hypothermia when I was 6.
Oh wow, what caused that?
Just walking to school. I'm old enough that sort of metal lunchboxes were the way to go. It was a fairly cold January or February, which is a thing that does happen here, although our February this year has been quite warm. So I was taking the long way around. I don't know why. Presumably the pipe that I normally would have crossed probably was iced over. So what was happening was that my hand was getting very, very cold holding the lunchbox, and so I was sort of passing it back and forth, and my hands wouldn't warm up quickly enough. And when you're, 6, a lunchbox is like a significant, portion of your body size. So I was like trying to stick it under arms and stuff, and couldn't come up with anything. And finally, I did the thing you should never do if you're dying of exposure, which was stop moving. I came up with the idea that if I could just stand still, I could have the lunchbox down, stick sort of both hands in, and warm up and get back. And my next conscious memory is in my first grade class with a cup of hot cocoa coming back from my lips. And I am told that a woman that ran a sort of corner store, in fact, that was the name, it was the corner store, that was close but not really in line of sight of where I actually was, had picked me up and got me the last few blocks and got me into school. And they sat me down in a chair and gave me some
Yeah,
hot
took care of
cocoa or something. Yeah.
Oh, that's scary. Like, just that one little moment there could have changed the whole trajectory.
Yeah, yeah. Well, it's a interesting thing, I suppose, to have in your backstory.
Well, let's go ahead and dive right in. What was your mindset 5 years ago, and how has it changed since then?
Well, I've sort of been gradually hardening my mindset around my project. I'm convinced that we are in the early phases of a general sea change in how society can function. And the reason I'm convinced about that is because the foundational assumptions for the philosophies that that undergird our society were falsified by Alan Turing. And so, to a certain extent, we can dismiss success out of hand as obviously false, which is a very bad position to be in when you're trying to actually make anything that could work. And so, over the course of the last 5 years, the increasing chaos that we see around the world and in our personal lives, I see as confirming symptoms of that belief. And I guess there's been a certain amount of anxiety generated, because, well, I have a reasonable candidate solution for one aspect of societal functioning. I'm increasingly convinced that we need reasonable candidate solutions for many, many other aspects of societal functioning, and I don't have any of those to offer.
I think at this point too, what's really interesting is that we kind of have this idea that we have to fix all of it ourselves, but the whole idea of society is that we're working together. So hopefully people like you or I who are coming up with ideas to fix certain problems can come together and take our solutions and combine them together.
Yeah. Well, that's basically a requirement for anything that winds up actually working is that
Yeah.
they have to be co-compatible with one another.
It's interesting too to think about how when people are trying to work on society, they're usually looking through one lens, and this whole show is talking about being like multidisciplinary, viewing your life through multiple lenses, and I think that's helpful when it comes to solving those problems.
Yeah. There's a concept I've been learning about in this context. I'd seen some of it before, but this thing called theory of mind, this idea of human capacity to actually conceptualize other human conceptualization. And the sort of simple way to understand this is the, action movie cliche of the person under threat looking shocked and causing their attacker to look behind them because the attacker can conceptualize what must have caused you to look shocked and be aware that there's a threat behind themselves.
Even worse than him, or something like that.
Right, something like that. Or to go second order and realize that you could be faking it and then, get conked on the back of the head because it's really there. But people who don't have that kind of theory of mind, extreme autistic spectrum people, for example, don't really have that capacity, won't in fact react to those sorts of cues because they can't conceptualize what's going on. But while we have sort of social amounts of theory of mind and people exist who can sort of manage a conversational crowd of maybe a dozen or so people and keep track of their things and sort of be aware of what the political temperature in the room is and so on. We've got the internet. We've got billions of people, and nobody can do that. And that's figuring out how to actually think about that sort of situation productively. I think is one of the approaches that's helpful for how to get multiple points of view to merge together into what I'm generally describing as superintelligences.
And I think also the ability to communicate with other people. And so something that I do on this show, for example, is look at the camera versus looking at you. If I'm looking at you, it makes it feel like I'm having a conversation with you. But then when you look at my face looking at something away from you, it looks like I'm looking away from you. There's a psychological response, like you were talking about with the whole shocked expression when someone's chasing you. So it's kind of one of those things where by putting yourself in someone else's shoe, like the viewer on the camera or the guest on the show, I change my actions based on that, and I think we just need to do that on a bigger scale. It's kind of what you're saying.
Yeah. And that would actually go towards whatever the morality and ethics of existing in our kind of world would look like. For example, perhaps camera displays should be redesigned so that cameras are centered inside displays, so that people would have two-way conversations that operated like that, at the cost of...
I've seen some.
Yeah. But yeah, currently displays are essentially, carrying on the kind of television typewriter design of computers. And lots of people use their screens for streaming content and would be probably disappointed with an ineradicable black dot sitting in the middle of their point of view.
Before we move on to the next question, I want to mention there's actually a really cool tool, I think by NVIDIA, where it's using AI. So I might be looking at you, but on the camera, it's taking my eyes and looking at the camera. And so it actually automatically does it through AI. It's insane.
Yeah, well, the deepfake technologies, exist across multiple platforms. And again, that's another point where sort of the morals and ethics, we've had vivid situations where people use those filters on their selfies or use their camera instead of a mirror and so on, and actually give themselves body dysmorphia because they don't physically look like what their camera tells them they look like because they put the filters on to make them not look like themselves. And if you are constantly exposed to self-images which are false, then that's what causes body dysmorphia. Adolescent kids, and mostly adolescent females, because of how much body change they go through, are the sort of most prone to this. But you can do it to literally anybody if you can control what images they receive about their own bodies. And in a world where cameras with incorporated AI are doing this, we can just do it to ourselves now.
Yeah. So going to the next question here, I actually wanted to ask you, on your profile, you say that you're an experienced public speaker and conversationalist. What do you personally see that as?
Well, so there's actually a sort of unconference here in Charlottesville. It's a technology conference, but basically it's a 2-day thing. I think I've been to 5 or 6 of them now. We just got restarted after the pandemic got over. And the way it works is you get together Friday night, everybody introduces themselves, and you sort of, circle around, have some pizza, and then people pitch ideas for talks that they would like to give, or talks that they would like to hear somebody else give, or just sort of discussion groups that they would like to lead and pull together. And then the attendees vote on which are the most popular of those, and then the top 20 to 30 ideas, depending on venue size, get scheduled out for the following day, and then we have them. And I've given 10 talks at that, plus 6 lightning talks.
That's awesome.
I also created a lecture series at a company that I worked with, where I wound up giving at least 3 dozen lectures on programming topics.
Well, when it comes to public speaking too, it's always kind of hard to get started, but there's Toastmasters around me. There's the unconvention you were talking about with yours. So I'm sure, regardless of where you are in the world, there's some kind of event or group that you can meet up with to try practicing your public speaking.
Yeah, I'm sure that's the case. There is a very harsh sort of first experience, probably. I was somewhat fortunate in my high school. We had a TV quiz team, which I got on. And basically the first time you're on camera in a Jeopardy, style game show situation, you don't say anything, because even when you know the answers, you don't buzz in quickly enough. Like you haven't. There's that break of there's some nerves, but it's just like you have to think about it. You're like, okay, I'm hearing this question. Okay, I heard that, and now I'm on TV, and I need to press the button, and now I'm on TV. Thought. Nobody else in the room had that thought. They just pressed the button, and so they beat you, and now you get to listen to somebody else say something. I think I was probably helped out. The format for my first time on camera, they actually had a round where they just did direct address. It wasn't just buzzing in, so you got to actually eventually do one on camera and sort of, okay, this is happening, this is normal. It's just like answering questions in back at school, and then once you're past that, it's basically fine. So it is. There is a first bad experience that you have to have before you realize that it's normal. But once you realize that it's normal, maybe it's not for you anyway. But it's at least that part of it goes away.
Yeah, it's still a skill that I think people should learn. Even if you don't enjoy it, having that ability to speak in front of other people is a very important human skill.
Yeah. I mean, there was a guy who's far better than I am, he does like three at every single one of our things. He's a professional public speaker, and his business actually grew enormously during the pandemic, and they're seeking out employees that have that skill, to do the initial customer contact and sort of build out and so on. So you have to be able to get in front of the board and do a presentation.
Well, it's definitely could be applied to many different areas as well. I had public speaking in high school, so kind of like what you had as an experience back when you're in that young, impressionable age. That helped a little bit, but after high school, I started doing videos and content like this where we're doing interviews and just having that presence on camera, using the hand gestures and trying to make sure it's not too wild. These little skills that just all add up, it definitely helps quite a bit. I remember working just a simple job at a Halloween store, and the crowd was massive, wrapped around the store. And everyone I was working with was not very comfortable at talking to crowds, talking to a whole bunch of people at once. I was sitting there having to block the door to make sure that there's someone watching it. And we needed to get everyone to shift around and be able to talk to everybody at once and project their voice confidently and eloquently in that point. And I was able to do that because of the skills that I learned over the course of those years. And I feel like that's probably applicable to kind of what you're saying as well.
Yeah, absolutely. It's a basically necessary task, and it's a thing I get a lot these days, because I'm trying to describe this complex mathematical idea to people, and lots and lots of people say, it's amazing how well you describe things or how you break down complicated ideas. And what I really do is do a lot of research, because lots of smart people have attempted to teach these very complicated ideas for centuries, and people have stumbled over sort of really good general use metaphors that work over and over again. And more often than not, that's how I actually became able to understand them in the first place. So this exceptionally easy explanation that they're complimenting me for is in fact the standard explanation and the way I actually managed to understand it in the first place.
I taught swimming for about a decade, and I the exact same what you're saying there. Like, something that seems complicated to a lot of people is how I learned how to explain it to other people simply. It's crazy. I think it was Feynman who said that if you can't explain something simple, then you don't understand it well enough.
Yeah. There's a passage in, I think it's his second autobiography, where he had just attended a lecture on the new particle physics, and he'd gotten out and was sort of cheerful, and he ran into a few students, and they were like, "Hey, yeah, what's going on, Mr. Feynman?" And he's like, "Oh yeah, this is really cool." And he starts trying to break down what he just learned, and he realizes that he can't do it. He cannot explain, the quote's something like, "If you can't explain something to an interested university sophomore, you don't understand it yourself."
Yeah. Well, speaking of something like not understanding well, one of the questions I want to ask you here is, what is your thought process when talking to someone who may not be as adept at conversating? So you or I might be able to handle a conversation well, but with someone that we're talking to who can't really handle conversation well, how do you handle that?
So what I do is try to feel my way through and elicit reaction as often as possible. This is actually also sort of how I program computers too. You just try to get, if you think you have something that means what you think it means, try to get the other party to sort of repeat it back to you or tell you something to confirm or disconfirm that you're on board with whatever's going on, and just do that cycle as much as you can. And then, for your part, when you're active listening in a conversation, try to help, like you just did, nod the mm-hms, keep that ball rolling to try to keep rapport going and see where you can get to.
Yeah, that's a good point. And I wanted to ask that for the sake of people who might be more shy or maybe not as adept at conversating, like I was saying in the question there. So something we talked about before the show actually is your podcast journey. How has that gone for you? Because you've gone on to tons and tons of podcasts at this point.
Yeah. It's going pretty well. It's still in the accelerating phase, so it's sort of hard to tell exactly what's going on. But it's gotten me some of the opportunities that I'm currently working with, and it looks like it may get me a few more opportunities to work with. I sort of want to get to either a plateau or sort of the back end of sort of tailing off, sort of get through the podcasts that would actually be interested in me and kind of have this thing, and then start trying to figure out how to go back to it for repurposing or maybe other potential, jags. But yeah, right now it's still pretty fun. The things are still sort of pouring in. It's keeping me busy, but not so busy that it's not interfering with the relatively small amount of effort that I actually need for support of the people that I'm working with. So far, so good, basically.
It's building out your brand presence for your personal brand, if you will, too, so people actually get to know who you are.
That's one of the things that has sort of come up is that I'd sort of been doing cold calling or word of mouth networking, and this has warmed up some of those cold calls to a fairly significant extent.
I'm kind of surprised that you haven't created much content on your own. So what is your thoughts on that? I mean,
I'm actually very bad at doing that. I have a rather severe dyslexia, and as my thesis advisor in college put it, I have an output, not an input problem. Two-way conversation is something that I spent a reasonable amount of my sort of elementary school time figuring out how to do. Writing without a dedicated audience target, my brain just goes blank when I try to do it. I've tried monologuing into camera. That doesn't really go much of anywhere.
yeah, I've tried that too. It's hard.
I've said on other podcasts, like, I'm not particularly interested in what I have to say because I already know what I have to say. So I don't need it. I don't need that for anything. And so it's since I already know what I have to say, it's hard for me to conceptualize, this person that's ignorant of everything except for this thing that I want to say that I need to talk to. But if I'm presented with one of those persons, then I can, there's a lot of mismatches, and I can try to fill in whichever gaps might be of common interest. That's what I'm actually doing. So you're doing me a tremendous favor by being a foil, so that I have something to actually talk about.
Well, have you ever thought about like having a co-host on a show or something like that?
It's not impossible. I have a friend who we've had very interesting conversations in the past, but he's a farmer and he's sort of perfectly happy to be doing that. One of the things I've been sort of picking at experimenting with is I've got transcripts of a number of my podcasts, and so
Oh yeah.
taking those and like putting them into these AI rewrite things to see what happens. So far, so bad, I'm afraid.
Yeah, they're not that great yet.
They're not really fully there, and one of the big issues is actually with sort of logic arithmetic. They're pretty good at purely verbal forms, but that they trail off into nonsense very quickly when given sort of quantitative tasks. And since I'm very much over on the quantitative side of things, it breaks down pretty badly.
I almost actually thought randomly, I was trying to make sure I was active listening, but this thought cropped up a couple questions ago where what if you took the transcripts of all the podcasts you were on and put it in a book? And then maybe even find a way to repurpose what you said too, like, but without the tool.
That's on the list of things to think about. In fact, if I get to a plateau or a trail off sector, I've probably spoken 500,000 words or something like that at this point. So
Well, and before I move on to this one last little idea, being able to, you said you did lectures before on for a certain company, maybe you could find a way to do educational lecture-based content and just really nail down that buyer persona, as they say. Like, I don't really like the persona concept, but for you, it might be really helpful just to have that person you can imagine in your head, like, hey, this is who I'm teaching. They don't know what I'm talking about. Let me teach them. And that might help you get that flow out.
Yeah, that's not impossible. Although, to date, I'm fairly happy with sort of the amount of varied content. I don't only and exclusively talk about Coordisc and CDM to everybody. I've done broader things on economics. I was on one podcast where I was just teaching some total layman about what crypto even was. I've had debates with people in crypto about the future of crypto. So those are still pretty finance related. I've even done podcasts where I just talk about math as a creative activity. And there was one pretty fun one where the hosts were trying to solve a computational riddle that I came up with. And they actually, well, they didn't solve the riddle. Once we started talking through the riddle, one of their attempts actually got me onto thinking about the fact that amoebas and bacteria are biological examples of something that in computer science is known as a quine, a program whose execution results in a copy of itself.
Those moments of transcontextual thinking are something I really like to hear about too. So you mentioned how you were talking about something more quantitative and like this riddle, and it's more logical, and you compared it to something that's more biological and nature-based. I thought that was kind of cool.
Yeah, well, one of the things I've been thinking about recently, I've gotten a lot of opportunities to talk about game theory in a lot of these podcasts, and my kind of standard line is that game theory is one of the most flippantly named things in human history, because what game theory is the mathematics of strategy. So it is, in one sense, this very serious subject, and in this other sense, it's got this name that sounds like something for children. But computational mathematics, I think, is properly classified as the mathematics of imagination, actually. The Turing's proposal for the Turing machine was a pure thought experiment. He wasn't saying, oh, I could build this thing and then, have a chess program or something like that. He said, imagine a machine that was designed like this, and then realize that you cannot imagine anything that this machine isn't capable of. So this machine encompasses imagination in some sense. And now let me show you how to imagine a particular version of that machine that can fully encompass imagination. And then let me show you things that machine cannot accomplish. And that therefore those things are completely impossible because you can't even imagine them being possible. And the thing he specifically showed was not even possible to be imagined to be possible was fully mechanically solving all integer math equations. So diaphatine equations, the integer-based math, have no general mechanical solutions. And this actually has implications for programming that go direct to, so like right now, one of the things that they talk about AI doing is generating code. And yes, some code can be generated by AI, but because code writing belongs to the category of things for which no general technique can exist, AI can't actually always write code. Neither can people, by the way. It's just one of these things that we're up against the outer limits of the possibilities of imagination on.
Because I've actually had ChatGPT make me code on multiple examples. Very, very simple code, mind you. But it was interesting what it came up with and how well it came up with it too.
Yeah. I call those from way back. I had a coding class in my high school. I call them hamburger programs because they gave us some problems of this is in Pascal of writing things to like run a hamburger stand and do the accounting for them. And yes, that kind of code is about as easy to do as the kind of math we show to 6-year-olds. And those problems all can be mechanically solved, but the tools that we use to show the kids that they can mechanically solve those problems can be utilized to ask questions which nothing can find solutions for.
Well, you segue into a topic that isn't so basic, but it is a good topic. What is game theory? How would you define it? Because you were talking about it, but let's define it for the audience real quick.
Game theory is like I said, it's the mathematics of strategy. It concerns what happens when you have multiple agents, each with objectives and decision-making capacity. And so you can model one-player games in under certain circumstances, but basically, anytime there's two or more agents that each have the ability to make decisions among two or more choices, and at least one of which, although it gets more interesting the more of them, aren't totally indifferent to all possible outcomes of the scenario, then such a thing can be defined as a game. And some of these things are games. Like the two of us could play rock, paper, scissors right now, and we'd both want to win, and there'd be basic rules of, rock beats scissors and so on. But they could also be things that we would not regard as games. One of the sort of bizarre things is that much of the mathematics of game theory was developed by think tanks doing Cold War strategy. So the mutually assured destruction theory that the Rand Corporation came out with was based on sort of modeling nuclear war as a game of chicken. And therefore, the way to keep people from crashing into each other was to make the potential of crashing into each other as bad and as certain as possible if you did anything other than chickening out, so that you would always attempt to chicken out. So that's obviously not really a game at all. That was sort of all of our lives that was involved in that situation. But as a consequence of that, a lot of the core theorems were actually proved by people who were under NDAs to the U.S. national security state and are presently still under top secret lock and key, and they're known as the folk theorems. People know that they're true, but the actual formal proofs aren't public knowledge.
Well, when you were talking about that game of chicken, it almost seems like in the quadrant of game theory of win-win, this person win, and the one point where it's lose-lose, the chicken theory almost makes me think that that's what's going to happen. It's like you both just lose in that case. It's not really win-win scenario when it's playing chicken.
Yeah. So one of the key things to understand with anytime you've got more than one person with more than one set of different attitudes, you are not enjoined to have a situation where victory is even possible. It might be that the best outcome that you can have is the worst outcome that you want, because that's all that's available. Like, other people will make choices such that no matter what you choose, you get the worst thing that can happen to you. And that obviously sucks if that's the scenario that's actually presenting itself for you. Even in win-win cases, there can be room for maneuver. One of the famous demonstrations of this is a thing called Battle of the Sexes, where a man and a woman are going to independently go to either the ball game or the opera. And while they would prefer to be together, and so being together is a win for both of them, There's a more male win where they're both at the ball game, and a more female win where they're both at the opera. So there's still something to be had there of whether you're in sort of your first choice or your second choice. And of course, there's also your third and fourth choice where you're sort of on the lose side and you're not with the person you actually love, but you're either at the thing you want to be at, or in the worst case scenario, you're both stranded at the wrong place without the other one.
I wonder what then would be the perfect scenario.
Well, the perfect scenario is basically being completely indifferent to everybody else, and it's sort of the obverse of the previous of the worst scenario. It's where no matter what you do, the best possible thing happens to you. So everyone else's choices are such that you're guaranteed the best outcome that you could have.
It honestly reminds me of Stoicism, and how like being indifferent about it would cause you like to not be as upset.
Stoicism is a good thing to sort of bear in mind, because one of the key insights of game theory, particularly sort of sequential or oppositional types of things, of stuff like chess, where you have an evolving situation, or things like rock, paper, scissors, is that choosing a strategy of indifference is effectively dominant over choosing strategies. So if we're in an oppositional relationship and I do something that gives you three choices, and two of those choices are great for me and one of them sucks for me, and the one that sucks for me is your best option, you're going to do the one that sucks for me. The fact that there's these other two choices that are great for me, it's not there's a 2/3 chance of something good happening. You have free will, you've got a brain, you're going to examine the situation and say, oh cool, I will make him lose now. And so it's very easy for people to sort of extend this and sort of say, okay, there's like 1,000 things that can happen, only one of them's bad. I've got like a 99.9% chance of something good happening. It's like, no, you don't. You have an absolute certainty of something bad happening because something bad is on the table. And so instead of doing this thing that gives your opponent the opening, what you should probably do is look around for something that doesn't give the opponent the opening. And sure, maybe it doesn't give the opponent the opportunity to mess up and give you these good outcomes, but assuming that your opponent's going to mess up and give you good outcomes is a little foolish.
And it also makes me think, maybe not so much in the opposing scenario, but if the person, like if you could have this delayed instant gratification and a little bit of empathy, you could put yourself in the other person's shoes and see what their options are as well, and find that more win-win scenario. Even if they are your enemy, perhaps their best case scenario that's best for you could be their surrender. And if you could try to convince them to do that, which honestly is obvious but doesn't seem obvious sometimes too.
Well, that gets into something called tough but fair, and that's a strategy that is operant under iterative conditions. So there's another game theory story called Prisoner's Dilemma, and this is by far the most famous one. And in this one, it posits two thieves who have committed a crime. They're definitely guilty. They've been captured by the police, and they're being sweated separately. And so each one of them can choose to betray the other one or keep quiet. If they betray the other person, they'll do better. If they both keep quiet, they were both brought in on something. They won't go away for the full bid, but they'll both do a little time. And if they betray the other person and they aren't betrayed in turn, then they'll go free. But if they both betray the other person, then they go away for a pretty long time. And so you have this scenario where sort of the best thing that could happen to both of you is that you both stay silent and you do a little bit of time, but you're out again. It's to your benefit to betray the other person, and it's to their benefit to betray you. And so in a sort of one-off scenario, you both betray the other person and get this sort of bad outcome. But in an iterative situation where you're going to be doing this over and over again, and in general, you can think about as you engage, arbitrary strangers, maybe it could benefit you to just mug people that you encounter. I mean, they have money. Money's great. You could, hit them over the head, take it from them. But we live in a world where tomorrow is another day, and people notice, and we have laws and cops and so on. And so if you were to do that under an iterated game, pretty rapidly people would realize that you're a monster who really doesn't belong around people and would do something about that. So in a situation where betrayal can be personally advantageous in the immediate sense, if there is a tomorrow, if there is going to be another game, if there is reciprocity, and if you don't know when it's going to be over, then people's behavior actually changes, and you get to that better state of being cooperative. And so tough but fair is the theory that what you should do is be nice, be generous, be giving, be good for your initial encounter with people, and then the second time you encounter that person, you return whatever you were given. You return betrayal for betrayal, you return goodness for goodness. So pursuing the tough but fair strategy, if everybody else is also pursuing it, then sort of everybody acts like saints. If you encounter saints, then you'll just act like saints. And if you encounter sociopaths, well, you'll be nice to them the first time, and then after that, you'll start pushing them away and punishing them for the sort of damage they're doing to society.
Interesting. It also seems like, too, that's talking on a more society level where, again, if you're all doing that more saintly thing, you're going to be more saintly. But in the thief scenario, you were mentioning how, like, if they both stay silent, they both end up doing the least amount of time, if we're together, I mean.
Yeah.
And in the most scenario where they don't rat each other out, it kind of reminds me that, yes, they might not be doing what's best for the big society, but they're following what the thieves society, that tribe of thieves, if you will. There's that thieves code where you don't turn in your fellow thief, even if they betrayed you, because they're still one of your fellow thieves.
Yeah,
Tribal
and
mentality.
in fact, that gets into an interesting consequence, because that scenario under iteration causes social cohesion inherently. This is where we get into evolutionary game theory, where if you have a lot of people playing a game that's highly iterative, where the strategic structure is constant over time, then eventually the strategies will harden around the sort of Nash equilibrium, the ideals kinds of strategies. And so that game, we call it the prisoner's dilemma because this is what we actually do to our criminal, is we attempt to do this. Doing that actually structurally causes mafia type behavior, like mob type behavior, where a criminal world will develop of out of society cooperation. And so it might in fact be unwise to structure our justice system in a way where we emphasize reward for confession in order to try to get that betrayal out of people, because while it might make one case easier, in aggregate over the course of society, it actually causes criminals to become organized and more dangerous. Yes.
Yeah. Well, and they often say, like, don't betray the mob because the mob will come after you just like the cops would. And so if you betray both, like if you cause a crime against the mob, then you have the cops and the mob against you too. And it's better to have organized crime than it is disorganized crime, as they say.
Yeah, maybe. There are, yeah. But that's the thing to think about in sort of the meta-strategic sense. When you set up a strategic situation, what you're doing is creating the baseline for an evolving behavior pattern. And if that evolving behavior pattern is inimical to your design, then you need to go back to the drawing board at the strategic level. And that's where I see what we were talking about, like how my mindset's been shifting. Once you realize that sort of the breaking point of reason and logic is recursion, which is what Turing demonstrated, then things that we all accept as basically normal, like lawyers being involved in legislation, become basically intolerable. And I don't know how you don't involve lawyers in legislation and regulation, and nobody else does either. But I know that it's guaranteed to be broken because the math says so.
Well, and I'm not endorsing crime. I was just using a statement I found somewhere else
Right.
too. Yeah. Moving on a little bit here. We've talked about like 4 different skills that you know at this point, and you almost seem algorithmic on your approach to learning new skills. So, what is the system that you might use to learn yourself that you personally do?
Reading. Reading's my kind of leading source of new knowledge. I try to read as broadly and liberally as I can. Because of a quirk of my memory, I need things to sort of make sense for me to remember them. So a part of what I do with reading is I try to find approaches to link whatever technique that's being presented to me into the things that I already have. So I try to incorporate and embody that. And then typically that's it. Another key idea is motivated learning. So when you have a problem, my first instinct is to try to learn something about that problem before I try to do something. I don't know if that's sort of the right answer. A lot of people, sort of stick their hand in the gears first to try to figure out what's going on, and that can definitely be faster than what I do. I like to stick to doing things that I understand, and so I kind of seek out that understanding. But there's a lot of powerful motivation you get from actually having an active problem to work towards. And in my observation, good ideas have a kind of infinite degree to them. So it's okay to only learn a little bit about something and get the little bit of utility that you get from learning that until you have that next problem that requires you to get a little bit deeper. And so that's for sort of day-to-day tasks, but for my professional development, I very consciously decided to go super deep on computational mathematics, just to make sure that I sort of understood the subject. And so just read stuff.
Yeah.
When they mention other stuff, go find that and read it too. When they mention other stuff, and eventually you've gone around the circle and you've read all the stuff, and that's it. You're there.
Here's the motto for this episode: read stuff.
Yes.
Well, and it's interesting too because you said learn enough to have that understanding of that subject, and there was that TED talk where they talk about how it takes like 20 hours to really get a good grasp of a basic grasp of a subject, and then once you need to actually learn more, then you have a prompt, like you're saying there, like you have a reason to actually learn more, then you can go past that 20 hours.
Yeah, I think that's reasonable. And if you have the opportunity to sort of learn direct practical knowledge from the world, I think that's valuable too. There's a lot of universe out there, basically. So finding stuff from there isn't all that difficult because there's a lot of it. And the stuff from there is generally a lot more valuable because it's all sort of guaranteed to be real. People who think that I'm interesting to talk to or valuable to employ, it's not me. It's stuff that I have picked up from the world, and I'm carrying around with me in my memory.
But those are what make up you. Your previous learning, your previous experiences, they make up who you are in this moment.
That's true. But I think there's a lot of there's a lot of very famous people who are effectively doing self-expression, sort of the rock star thing of I'm going to go party vicariously for a billion people, that kind of thing. That's just not particularly valuable, really, because that's just them. And it's not as useful or creative as some new shell that happens to be picked up off a beach, which is how Newton described what he did.
How do you balance all your various skills and areas of knowledge?
I really don't. I don't really have the capacity to do more than like one thing at a time, so I just do whatever the thing that I'm doing at any given time. So, sometimes I'm asleep, sometimes I'm prepping food, sometimes I'm, washing myself or taking a walk, sometimes I'm working on my company and, or in a podcast, or at my day job back when I had one of those. And that's sort of it.
And a lot of people kind of see that question and they think of multitasking. I'm not thinking like you're going to be sitting here drawing over here, writing over here, and cooking over here. It's more of like time management throughout your week because you have all these different skills. Do you spend time on game theory, on going on podcasts, and that kind of thing? Like, how do you particularly like do your schedule, if you will?
Well, so for one thing, I do multitasking to some extent. I can read and appreciate music at the same time, for example. So that's a thing that I will do. And every once in a while, while I'm walking, I can maintain two separate thought streams in my head at once that allow me to sort of break out. We were talking about that theory of mind before. Using that as an approach to be able to increase the abstract scope of my theory of mind conception to be able to deal with the kinds of problems that I'm coping with in game theory comes in. But mostly I sort of, roll out of bed, try to schedule some podcasts, check LinkedIn a little bit, check the news sites, and kind of see if there's been any physics or math, breakthroughs, and then I kind of roll through that a few times a day, and then that gets sort of broken up by meals, and then it's time to go to sleep. So that's sort of what my days look like these days.
That dual stream of thought consciousness was really interesting too. That's why I like that question, because that question is like, how do you balance all these different skills? It's kind of a simple question, and honestly, it mainly is a transition to the question that I ask every guest, which we'll get to in a moment. But this show, the reason why I do these interviews is not just to have a great conversation, because I'm obviously just enjoying this as much as you are. We're having this moment of like building on top of each other's ideas, and it's a great format to have this stimulation, if you will. But I also want to understand the mental model behind people who are multidisciplinary. And what you said there was a great example of that, where you personally are able to appreciate music and read at the same time. I really kind of can't. I'll start listening to the music and stop reading and go back to that. I'll switch between them. But you being able to also go for a walk and have two different streams of thought kind of intertwined and switching back and forth, I thought that was kind of cool.
Yeah, so I was in the games club in my college, and I find that one of the ways to study a game, and having now sort of learned game theory and sort of walked through this, I was sort of accidentally stumbling across ideas that if I'd run with them further might have even gotten me all the way to reinforcement learning, which is the sort of all the rage in AI, but sadly it never occurred to me. One of the sort of cliches, I guess, in like popular culture is people playing chess against themselves. And I've done that a couple of times. I've done it. I usually, what I've done more of is played much more complicated games than chess by myself, with more than just two players. And the reason you do that isn't to win. The reason you do that is to study the game itself. So you're trying to make the best moves that you can, but you're not trying to fool anybody else because you can't. You're just there. but by taking on all the roles, then you can control what's going on and see these things from different points of view. And running through a game 3 or 4 times by yourself, taking on the other players' points of view, starts showing you the strategic understructure of the game, what works, what doesn't work, how the game's actually put together and what makes it go. And that approach for thinking through system design becomes incredibly valuable because a system needs to have multiple users. So one of my rules for system design, for example, is kind of no administrator panel. However my users are interfacing with the system, that's how I interface with the system, because I don't want to separate my understanding of how the system's working and what's supposed to happen from what my users are experiencing, because I don't want my users and I to disagree about how the system works. And so having that kind of second mindset, if you will, I think is sort of a valuable tool to develop in being able to think through the structure of ideas, and kind of be able to test, devil's advocate things from a position of not kind of, opposition, but just from like rolling through, like what's the next good thing to do in each situation from each perspective. And it is challenging, to do it, but it's
Well,
when you're talking about multidisciplinary types of approaches, the key to multiple disciplines is sort of multiple discipline practitioners. And so having that kind of Hydra-esque point of view, I think, is a key to building systems to engage that sort of behavior.
the only time I've ever played against myself was on Wii Tennis, and I was just playing both sides. But that was certainly a lot of fun. The way you're describing it, though, sounds to me more like real-time strategy games where you have a civilization you're building up, and you're switching between different civilizations and kind of fighting between them and choosing, or maybe not fighting even too, maybe collaborating, but like you're choosing what that particular civilization needs to do to win. And by doing those actions with that Civ 1, then Civ 2 will see that from a different point of view, and you have to figure out that different dynamic.
Yeah, and you could think, even at a very basic level, I mean, in general, people figure out how tic-tac-toe works pretty rapidly playing it against other people. But you could think about playing tic-tac-toe against yourself and just sort of working through. And in fact, I spent a fairly enjoyable afternoon one day, three-dimensional tic-tac-toe on a 4x4x4 grid is actually a guaranteed forced win for the first player. And it was in college, and I was stretched out on my mattress, and I just visualized it. I worked through the set of strategies that would allow a first player to guarantee a forced victory in that game. And it changes the way you think about the game to sort of work through that structure. And I mean, that one's not that hard, fortunately. Like, I wouldn't be able to do something like that with a higher dimensional, higher order tic-tac-toe. It'd be too
Or
big.
3D chess or something like that.
Yeah. What is there, like 5D chess now? That one with like the time, there's a multiversal chess version now. Yeah, it's gotten kind of nuts.
As much as I would definitely dig into that video game topic, I do want to ask you something that I ask all my guests is, what is a polymath to you?
So I think a polymath is just somebody with multiple expert or better level masteries, basically. I think that in the modern world, the easy path to polymathy is actually mathy, if you will. We've sort of discovered that math is a considerably more extensive subject than anybody had really imagined before, and so there's a lot to be gained by figuring out the actual mathematics of a situation and then being able to apply millennia of genius to problems that have sort of not yet been exposed to that sort of bright light. There's actually a John Brunner science fiction story called Polymath, and that's more or less his take. It's a Silver Age sci-fi, so the characters are potential colonists, but their ship like crash lands on the wrong planet. So like half the or more of the colony that's to be dies, but one of their polymaths is in fact still alive, even though he's just a kid. But it turns out that the hard problem for colonizing a new world is being able to deal with whatever the hard problems turn out to be, because you don't know what they are going to turn out to be, and that's where having somebody with the perspective of multiple discipline and the ability to sort of make connections across disciplines becomes the key to being able to deal with bizarre situations that come up.
There is a theory, I don't remember what institute it was off the top of my head, but it was talking about how during the spread of human evolution going into like Europe and some of the Eastern areas, that the reason why humanity as Homo sapiens were able to survive instead of maybe Homo erectus and Neanderthals, the reason why they kind of faded out and why sapiens actually survived was because the generalists were able to adapt way better than the more specialist brethren of our kind of cousins in that whole scenario. It's because the generalists were able to adapt to those new surroundings.
That's certainly possible. If you have the capacity to be generalist, omnivores have advantages over either carnivores or herbivores. But don't underestimate the power of getting the right niche. Crocodiles, or crocodilians at any rate, evolved before the dinosaurs, and they are substantially the same today, because it turns out that ambush predation at waterholes is a very stable way to get your calories here on planet Earth.
And I think a lot of people misconstrue the idea of polymathy as like pursuing all four things at once, which I mean you certainly could do, and some people I think almost have to depending on what they're trying to learn. But the actual better probably approach is to specialize first and then spread out and use that one main niche of knowledge to translate into other topics and learn those other topics through that translation.
Yeah. Well, for me, I'm essentially forced to do that because I won't actually be able to remember things that I can't relate to things that I already know. But one of the really big things in mathematics, particularly over the last, the modern period, effectively, is that the big breakthroughs have been discovering the connections. So going back to Descartes and connecting geometry and algebra, and sort of then Leibniz and Newton opening up the new calculus and having connections between that and both of those subjects, and so on. And there's now something called the Langlands project, the sort of an early step of which was the proof of Fermat's last theorem. Andrew Wiles essentially showed an equivalency between two what appeared to be wildly different branches of mathematics, that allowed the theory of calculus on complex numbers to operate on number theory in a way that then demonstrated that that there were no integer solutions to the question a to the n plus b to the n equals c to the n if n is larger than 2, which people were pretty sure it was true, but they couldn't prove it for several centuries. And the Langlands project is essentially building off those connections and creating this sort of massive plan of connections of parts of math that are currently not well translatable. And so there's a lot to be had there, because if you can mathematicize your discipline, not only do you sort of automatically get all of the trans-mathematical insights that can now be applied to your discipline, but if there's any mathematization of any other discipline, then if that link exists, then you can get that translation between disciplines as well. And this is something that physics and chemistry in particular have been doing quite a lot of with the quantum revolution over the last century and change.
Well, and like quantum computing, for example, too, is that convergence between those two sciences as well, or even chemistry, considering the different aspects. But one thing that I would keep thinking of is the fact that mathematics is like this universal language, and you almost kind of touched on that there too.
It's classically known as the queen of the sciences, and numerous people have posited that if we were to need to communicate with inhuman intelligences, mathematics would be the only language that we could hope to rest our case upon. And yeah, I'm pretty convinced that mathematics is about as all-encompassing as it's possible to imagine. And so I think there's a lot of value to understanding systems in those terms in order to deal with the sorts of corruption and degradation of systems that we are currently dealing with.
Yeah, that definitely transitions to what our next topic would be too, but it also makes me think, since math is the universal language, not only just to living beings, but the Fibonacci sequence, the golden ratio, and just how the universe works itself, it definitely makes a lot more sense from what you're talking about.
Yeah, well, one of the fun ones I like is the prime sort of pupating stages of cicadas. Are you familiar with this? Do you know what cicadas are? Do you live in a place that even has them? Okay.
Every 17 years or so, yeah.
Yes, 17. Why 17? Why not 18? Well, 18 is divisible by 2 and 3 and 6 and 9. So if there was a species that had a 2 or a 3 or a 6 or a 9-year cycle of behavior, it would be able to sync up with the cicadas and eat them. Why not 16? 16 is divisible by 2 and 4 and 8. Lots of chances. 24, 2 and 3 and 4 and 6 and 12.
Yeah.
But 23, 19, and 17, and there are species of cicadas that do all three of those things, are only divisible by 1 in themselves. And so the species can't sync up with them. And so while there can be natural disasters that occur in the year that they come out that really hits them, any sequence would have to be at the same pace as the cicadas in order to keep track. And so you'd have to evolve a 17-year cycle in order to go after cicadas.
That's crazy. I wonder if humans could do it just to get rid of them.
Well, you know, we know the answer. Presumably, we could put some work behind that at some point. I do not find their cries enjoyable, so I would sign up for that project. Yes.
All right. So, what is a coordinated discovery market?
So the critical difference is the coordinated discovery part. So a market's just any kind of, just the same as any other market. It's a place, these days they're online, where buyers and sellers can come together to exchange goods at a given price. What I have changed is how the price discovery occurs, and what I have done is created a prediction market to bring together the opinions and negotiation positions of everybody into a single integrated, coordinated fashion. And the key change there is that rather than attempting to find a price, the price of this particular instant, and then next instant finding another price and so on, or doing futures contracts and tracking the instantaneous change of opinions about futures contracts. What I'm attempting to equilibrate towards is the sequence of prices at trading opportunities over an extended period of time. So what's the price going to be tomorrow? What's going to be the day after tomorrow? The every day of next week, every day of next month, every day of next year, every day for the next 10 years, or even the next 100 years. What's our current best guess? And everyone can contribute knowledge to that fund of where people think that the clearance price is heading. And the system will integrate all those opinions together, tracking both the costs that people imposed upon themselves to get their opinions integrated and the amount of their information that's resident in those prices. And so when the time comes that the price is actually live and now has all the integrated information of everybody that's been working in this marketplace from its inception up until whatever day that turns out to be, we can precisely determine how much credit each individual contributor has towards this final integrated price.
How would you describe a coordination game working together?
A coordination game is a strategic situation where individual deviation from the group behavior harms the individual. It might also harm the group, but it has to harm the individual. So the coordination game that everyone sort of plays every day here in my neck of the woods is, what side of the street do you drive on? Driving on the wrong side of the street is not going to work out for you for very long. It might also not work out for somebody else at the same time, unfortunately, but it's definitely not going to work out for you.
Yeah, because it's obviously going to be dangerous and not cause a
Right.
crash, something like that. Yeah. So we're all coordinated in the act of driving on the right side of the road here in the U.S.
Yes.
How would you say Coordisc plays into all of this when it comes to the CDMs?
Well, Coordisc is sort of my company to sell the idea. The way we presently work as a society is that things happen through corporations, not individuals. So, Coordisc is the corporation that sells the idea of CDM to people. That's either through licenses or potentially bringing me on as a consultant. The idea itself is patent pending, so there's currently no legal requirement to license the idea. There's some code that's under Creative Commons license that will remain essentially unencumbered outside the United States, even in the event that the patent comes through. So that code can be picked up under that license. So as long as the person's publishing what they're doing and sort of making changes also available under the same license, that's covered in that fashion.
It definitely seems like you're trying to go for a decentralization approach too, to help get rid of that single control frame.
Well, that's a tricky thing. See, markets are in fact a centralizing technology, but at the same time, what they're doing is, even without the coordinated discovery, they're coordinating the behavior of a decentralized group. So markets are in fact an example of an artificial superintelligence, and what's very impressive about this is that they're like an 8th century old example of an artificial superintelligence. What the market's doing by bringing supply and demand together is allowing hundreds, or these days tens of millions of businesses to coordinate with one another, to match their own internal businesses and maximize their own actual livelihoods, given the co-needs of everyone else that they are competing with on their side, and also everyone else that they're competing for on the other side of whichever trade they're on. So in that sense, markets are a centralization technology. In sort of the more important sense, the way that that superintelligence functions is by being able to take in the opinions of the participants in the market and clean the noise out of those opinions in a fashion that provides a wise, or at the very least economically viable organization of that industry. Centralization of that intelligence is what allows that distributed and consequently much more stable market to operate without hiccups and gaps. One of the things that we are seeing with the rise of computers and the vast drop in the cost of accounting and sort of organizational checking is these sorts of rise of supercorporations that are operating multinationally and all under one roof. And that's, as we've now seen with supply chains and issues and so on, is a very fragile way to actually organize an economy, because you lose the superintelligence, and while some of these people are pretty bright, they're not as intelligent as them plus hundreds of millions of other intelligent advisors all coming to the true common consensus.
It seems like you're taking a system that's a one-way approach, the top-down market just to the people, and making it a two-way approach where people can actually reach back up and impact that market much more.
The existing corporate model has particularly as those stacks have grown, have become very top-down. A lot of countries are ossifying towards this as well, with executives gaining a lot of power basically through mass communication. People have lost identification with their governments of local legislatures, for people that have governments that even have something like that, because the president gets on TV and talks directly to the people, and so you see more of what the most remote person in your government does than you do what the most present person in your government does, and that creates more of a disconnect between citizen and government than we've seen since the monarchical period, where the king was in some cases literally deified and seen as sort of totally separate.
Like the Holy Roman Emperor too, or the fact that in Eastern cultures a lot of the emperor there would actually be deified as well.
The key part of Roman imperial politics was worship of the emperor, and that was in both the biblical stories and the histories of the time sort of a big sticking point for the Jews and then the Jews and the Christians, was that they would have to worship or give offering to the emperor, and they were like, yeah, that's not I don't know if you've read this book, but that's not what we do here.
Well, I got one more question for you, because something that I saw in your profile and education was that you studied nuclear physics, and I would be remiss if I didn't ask about that on the show. So just to start off with, why you went into that?
So I got out of high school and kind of went sideways to the University of Virginia. So I'm in Charlottesville. I was born and raised here. UVA is, right across town from where I am right now. It was closer to where I grew up. I had studied math there because I got into several of the accelerated math programs at the city schools, and they had a program. They've now downgraded, I believe, to sending people to the community college, but at the time, if you finished out any course of study, they would send you to UVA to keep studying. And so there were a couple of kids. They were like a year older than me, but their parents had divorced, and they had been raised mostly with their father in Belgium. So they were native, like French, Flemish, Dutch, German, English speakers, and they had come back to be with their mom for high school, and sort of like just tested out of the language program in Charlottesville High School instantaneously, and got the school to send them over to UVA to take language classes for languages that they were native speakers of, basically, and that allowed them to get some college credit, cribbed into their transcripts. So anyhow, I was over there taking math. So then I got in and started going to the engineering school, and you had to declare a major at the end of your first semester. And I wasn't. Most of the people in engineering school were there to become a very specific kind of engineer. They wanted to build bridges. They wanted to, crack chemicals. They wanted to be able to say, "I'm a rocket scientist." I had all of those, in the rooms around me when I was in my freshman dorm. I was just like, I don't know. Apparently I'm good at math, and evidently this is what people that are good at math are supposed to do with their lives. So I was just sort of hanging out, and so I wound up in something called engineering science, which was for people that wanted to either design a multidisciplinary degree with an eye towards graduate school, or were trying to get into a specific graduate program for which no undergraduate program existed. So there was a biomedical engineering. We have a pretty good teaching college, medical college here, or teaching hospital. So biomed engineering is something that UVA is okay-ish at, and so, but there's no undergraduate program, so it's a thing that you could sort of slide into. The thing you're not allowed to do is grab the major as this smorgasbord where you just wander around grounds taking whatever you felt like, which is what I did. So they let me do it anyway.
That's
and
amazing.
So I just took classes that looked either interesting or had professors that I knew were good professors. And that wound up, the year before I'd started as a full-time student, they had shut down their nuclear engineering department as an undergrad thing. Now, the reactor was still on grounds. And so parts of the department still existed. They had a few grad students lying around. But one of my favorite sort of survey engineering course instructors was in the nuclear engineering department, and he was teaching a class on reactor design and safety. And who wouldn't want to know how to design a safe nuclear reactor? That's the kind of practical, knowledge that I was trying to gain in my college career. So I went into that class in sort of a thought experiment phase. He pointed out that there's this physical thing called delayed neutrons that enabled humanity to commercially exploit nuclear power. That without this physical fact of the universe, all nuclear reactions would be bombs, and it wouldn't be possible to create safe or safe-ish nuclear reactions. And when you tell larval engineers or even experienced engineers something is impossible, they push back. So we did, and he batted us down easily, because that's what experienced engineers do to young people that don't know anything. But I spent the remainder of that lecture imagining a science fiction reactor that would be able to turn itself off at the speed of light, and consequently be able to be utilizable. And while that idea was wholly impractical and clearly could never be built, it turns out that pairing a beam system to a particular kind of reactor array is a real proposal. That one of the PhD candidates was in fact working on a computer simulation of such a device, and that potentially that is a technology that could enable significantly safer and less proliferatory utilization of nuclear technology as a power source than the kinds of nuclear technologies that we presently pursue. So that was all news to me, but but he then introduced me to another professor who became my thesis advisor, who was also a pretty good teacher. Wound up taking class from him, including the nuclear radiation detection laboratory that constituted something like 75% of the lab credits that I needed to actually graduate, and for which I did not have to turn in weekly lab reports, which would have been a real trial with my dyslexia, and instead was able to simply do a oral examination at the end of the year. So I'm still perfectly comfortable telling you what the procedures and results from those experiments were to this day, because I did them, so I remember them. But yeah, that's what got me into the nuclear engineering department.
So glad I asked too. It's fascinating. And you mentioned the whole multidisciplinary learning, because I've definitely noticed that with a lot of more liberal arts, but even some sciences, where a lot of undergraduates are trying to do these interdisciplinary study degrees where they're pulling from the multiple different areas. It's very cool to see that it was done more in a science-based degree system too, though.
I call my degree the mad scientist degree. It's an engineering science degree, but the things that are sort of important for the engineering science degree is what you do with your labs and your science electives. And my science electives were genetics and relativity, and my lab electives were robotics and radiation detection. So I am fully qualified to star in Universal horror picture from the 30s.
That's awesome. Well, and something that just to plug this in a little bit because it kind of fits this particular topic, is the modular degree system that I created. It's because of people like you who wanted to learn from multiple different areas, but you at least were able to do it, but a lot of people aren't, and they want this modular learning experience and a system that can actually work with that. And that's why I created that system. But wrapping up here, where could people find you online?
Well, the easiest way to get to me online is my email, noahphealy@yahoo.com. You can also find me on LinkedIn, Noah Healy there. There's only, as far as I'm aware, 2 Noah Healys on Earth, and being the first one, I got the one without any tags on it. There's also a website, Coordisc, Coordisc, where you can learn more about this system. There's links to video that sort of explain what's going on, as well as a download link for the white paper.
I'll definitely have links in the description too for you. And I think the other Noah Healy is like a soccer player or something like that.
Yeah, so I've been sort of following his career because Noah Healy's a unique enough name that I used to have the Google page all to my own. But now, yes, now he's around. In terms of call to action, I'd say if you have any interest at all, please learn as much as you can and reach out and sort of join me. We, humanity, need an economy, and the one that we have is breaking very, very badly and increasingly rapidly. So if you don't want my candidate solution, get into the history and the math and come up with a better one.
You could always take the whole idea of improving upon other people's thoughts too is part of human history too. So perhaps you give the seed that the next person could build off of because of what you have created too.
Yeah. So my idea is actually built around an approach that I call negotiation games, which is essentially the coordination game we were talking about before, that you add a computer program to as a new player that allows the game to gain a flexibility that standard coordination games don't innately possess. And negotiation games, they're just out there. That's as far as I'm concerned, pure math. That isn't patentable material. And so if you can find another application for a negotiation game in the situations that you find yourself in, have at it.
That's awesome. Well, once again, this is Dustin Miller, PolyInnovator, and Noah Healy on the Polymath Polycast. Thank you for joining me.
Thanks for having me again. This was a lot of fun.
It was.